Hello everyone. In the previous chapter, we discussed the concept of random variables, which is defined as a function that assigns a numerical value to each element of the sample space or to each outcome of a statistical experiment. And you also learned from the previous chapter that a random variable has an associated probability distribution. And to be specific, if whenever the random variable is discrete, its probability distribution is also discrete. And its probability distribution is called the probability mass function. Now, you also learned in the previous chapter about finding out the expected value of a random variable x, which is also known as the mean of the random variable x. And you also learned how to obtain the variance and the standard deviation of a random variable x. Now, in this chapter, we focus on special types of discrete random variables which are associated to certain discrete probability distributions. So let us recall first what is a discrete random variable. So if the random variable x represents a discrete quantitative variable, then x is said to be a discrete random variable. Examples of discrete random variables that you learned in the previous chapter are number of heads in tossing three coins and also number of students who are absent in a class. Observe that these variables are obtained from a counting process. Now, the numerical values associated to the number of heads and number of students result from a counting process. Now, the probability mass function, which is the probability distribution of a discrete random variable, is represented in table form. So in table form, you will see the possible values of x and their corresponding probabilities. So for example, in tossing three coins, the PMF for the number of heads x is given as follows. So if the toss would contain no head, then the probability is 1 over 8. If the toss contains exactly one head, then the probability is 3 over 8. Now, if the toss contains exactly two heads, the probability is 3 over 8. While if the toss contains exactly three heads, then the probability is 1 over 8. Now, you learned from the previous chapter that if you get the total of these probabilities, the total will always be equal to 1. So for this chapter, we focus on the special types of discrete probability distributions. And we shall discuss the binomial distribution, the hypergeometric distribution, and the Poisson distribution. So for this video, we will discuss the binomial distribution. Okay, so a binomial random variable is defined from a binomial experiment. And this binomial random variable is associated to a binomial distribution. So what is a binomial experiment? Now, this experiment consists of n repeated trials. So for example, out of 10 students surveyed, that phrase would mean that the number of trials is 10. Now, each trial results in an outcome that may be classified as a success or a failure outcome. So for example, if we want to know the number of students who have eaten breakfast before coming into class. So if the student have eaten or has eaten his breakfast, then we can consider it as a success outcome. Now, if the student has not eaten his breakfast, then we consider it as a failure outcome. Okay, now the probability of success is denoted by small p and it remains constant from trial to trial. So this means that the repeated trials are independent of each other. So whatever outcome that we get from, let's say, the first trial is independent of the chances or odds that that outcome will occur in the next trial. So that's why the probability of success remains constant from trial to trial. Now, for a binomial experiment or binomial distribution, the probability of a specific value of x is given by p of x equals n combination x times the probability of success raised to x times q, which is defined as the probability of failure, and it's defined as 1 minus the probability of success. And this probability of failure is raised to n minus x. So this random variable x is actually defined as the number of successes out of the n trials. And n minus x here is the number of failures out of n trials. So that's why in the binomial distribution, the possible values of x would range only from 0 up to a maximum value of n. Now, since this binomial distribution is defined from a binomial random variable, then we can also define the mean of the binomial random variable and the variance of the binomial random variable. So we shall have a special formula for this because the binomial random variable or the binomial distribution is a special type of a discrete probability distribution. So the mean of the binomial random variable x is defined as the number of trials n multiplied by the probability of success, while the variance of the binomial random variable x is defined as the number of trials times the probability of success times the probability of failure. And you already know that in the previous chapters that to get the standard deviation of the binomial random variable x, then we shall get the square root of the variance. So it's just the square root of n times p times q. Okay, so recall that q is again obtained by subtracting the probability of success from 1. So let us have an example. In a certain city, district, the need for money to buy drugs is stated as the reason for 75% of all thefts. Let us find the probability that among the next 5 theft cases reported in this district, exactly 2 resulted from the need for money to buy drugs. And letter B, at most 3 resulted from the need for money to buy drugs. So in this example, the binomial random variable x is defined as the number of successes or the number of theft cases resulting from the need for money to buy drugs. So that means the person's reason for theft is because he or she needs money to buy drugs. So we're counting the number of theft cases resulting from this particular reason out of the 5 theft cases. So it's like counting the number of theft cases that resulted from the need for money to buy drugs for every 5 theft cases. Okay? So number of theft cases uh, because of number of theft cases resulting from need for money to buy drugs. Okay, so in this case, the possible values of x could be 0, 1, up to a maximum of 5 because we only have 5 theft cases in our experiment. So x equals 0 means that out of the 5 theft cases, none of those resulted from the need for money to buy drugs. So meaning all the theft cases resulted from other reasons. Now for x equals 1, that means that exactly 1 out of the 5 theft cases resulted from the need for money to buy drugs. While x equals 5 means that all the theft cases considered resulted from the need for money to buy drugs. So if we are going to form the probability mass function of the binomial random variable x in this example, we have the following table. So we have that binomial random variable x, and it ranges from 0, 1, 2, 3, 4, and 5. And in the second row, you can find the P of x or the probability of a specific value of x. Now for letter A, for item A in this problem, we want to know the probability that exactly 2 out of the 5 theft cases resulted from the need for money to buy drugs. So that means for finding the probability that the binomial random variable x is equal to 2. And this is equal to P of 2. And from the probability table or from the probability mass function, it means that we're going to find out this particular value here. Okay? And now using the formula of the binomial distribution, now recall that the formula is n combination x times the probability of success raised to x times the probability of failure raised to n minus x. So in this problem, the number of trials is 5 and the probability of success or the probability that the theft case would result from the need for money to buy drugs is 75%. So this would tell us that the probability of failure is 1 minus 0.75 or 0.25. And then the random variable x would be the number of theft cases resulted from the need for money to buy drugs. So plugging in these values into the formula, then P of 2 will be 5 combination 2 multiplied to the probability of success, which is 0.75 raised to 2, multiplied to the probability of failure, which is 0.25, raised to 5 minus 2. And using your calculators, this will give us 0.0879 or 8.79%. So this value here is just one out of the 6 probabilities in this particular probability mass function. Now for letter B, we want to find out the probability that among the next 5 theft cases reported in this district, at most 3 theft cases resulted from the need for money to buy drugs. So for letter B, we want to find out the probability that x is less than or equal to 3. So this is actually P of 0 plus P of 1 plus P of 2 plus P of 3. So in this case, we are going to use the binomial distribution formula 4 times using the values of x 0, 1, 2, and 3. Now, if we go back into the table in the previous slide, the item B would mean that we're going to get the sum of these 4 probabilities. Okay? But however, no, in this example, we can also treat this problem as 1 minus the sum of the probabilities that x equals 4 and x equals 5. So if we're going to use the complement and then subtract it from 1, we get no, the same value of the probability. So I think no, this solution here would be easier no, because we're going to use only the binomial formula twice using x equals 4 and x equals 5. Okay, so now using this formula here, no, we're going to get 1 minus 5 combination 4 times the probability of success raised to 4 times the probability of failure raised to 5 minus 4, which is 1. This thing here is the probability that x is equal to 4. And then if we add it to the probability that x equals 5, we have 5 combination 5 times 0.75 raised to 5, and then times 0.25 raised to 5 minus 5, which is 0. So this solution here will give us the probability that x is less than or equal to 3. And this thing is equal to 0.3672. Okay, now this time, let's determine no, the expected value of the binomial random variable x. So recall that in this example, no, the binomial random variable is the number of theft cases resulting from the need for money to buy drugs. So since we know that this problem falls under the binomial distribution, the expected value of the binomial random variable x is given by the formula n times p. And we know that in this situation that n is equal to 5 and that the probability of success is 0.75. So this will give us 3.75 as the expected number of theft cases resulting from the need for money to buy drugs. So we can interpret this as there would be, out of the 5 theft cases, there would be either 3 or 4 theft cases that would result in the need for money to buy drugs. And then, for the standard deviation, we shall compute for the variance of the binomial random variable x, and it's given by the formula n times p times q. And this is equal to 5 times 0.75 multiplied to 0.25. So just use your calculators to compute the exact value of this variance. However, in our problem here, we want to find out the standard deviation, and the standard deviation is just the square root of the variance. And just use your calculators to compute this particular value. Okay, let's proceed to another example. According to a survey by the Administrative Management Society, 1/3 of US companies give employees 4 weeks of vacation after they have been with the company for 15 years. Let us find the probability that among 6 companies surveyed at random, the number that give employees 4 weeks of vacation after 15 years of employment is anywhere from 2 to 5, and letter B, fewer than 3. So in this situation, it's under the binomial distribution because there are only 2 outcomes. It's either the company will give employees 4 weeks of vacation after 15 years of employment, or the company will not give employees 4 weeks of vacation after 15 years of employment. But in this problem, we are counting the number that give employees 4 weeks of vacation after 15 years of employment out of 6 companies surveyed. So in this case, n is equal to 6, and we want to count the success case in which means no the success case which means the number of companies that give employees 4 weeks of vacation after 15 years of employment. Now, since n is equal to 6, then the binomial random variable would range from 0, 1 up to 6. So x equals 0 means that out of the 6 companies, none of them would give employees 4 weeks of vacation after 15 years of employment. While x equals 1 means that exactly 1 out of the 6 companies will give employees 4 weeks of vacation after 15 years of employment. While x equals 6 would mean that all the 6 companies would give employees 4 weeks of vacation after 15 years of employment. So if we want to construct the probability distribution table, the table will be as follows. So we have x and its probability, and the values of x would range from 0, 1, 2, 3, 4, 5, and 6. Now, since question A is looking for the probability that the number of companies that give employees 4 weeks of vacation after 15 years of employment is anywhere from 2 to 5, then that means we want to find out these 4 probabilities. Now, after finding out these 4 probabilities, we add them now to get the answer for item A. Now, for letter B, if it says fewer than 3, that means we are computing the probability that x equals 0, x equals 1, and x is equal to 2. So for letter A, that is the probability that x is anywhere from 2 up to 5. Okay, so anywhere from 2 up to 5. So this is equal to the probability that x equals 2 plus the probability that x equals 3 plus the probability that x equals 4 plus the probability that x is equal to 5. Now, the probability that x equals 2 is computed as 6 combination 2, that's the number of trials, combination x, which is 2, and we multiply it to the probability of success. So the probability that a company would give employees 4 weeks of vacation after they have been with the company for 15 years is 1/3. And we shall raise this to 2. And then it is multiplied to the probability of failure, which is 2/3, raised to 6 minus 2, which is 4. And then continuing for the rest of the solution, we have 6 combination 3 times 1/3 raised to 3 times 2/3 raised to 3 plus 6 combination 4 times 1/3 raised to 4 times 2/3 raised to 2 plus 6 combination 5 times 1/3 raised to 5 times 2/3 raised to 1. Now, as an alternative solution, this problem can be also obtained by subtracting, no, the probability that x equals 0 plus the probability of x equals 1 plus the probability of x equals 6 from, from 1. And using these two solutions, we shall get the answer 0.3196. Okay, for letter B, we want to know the probability that x is less than 3. So this means that p of 0, we get p of 0 plus the probability of 1 plus the probability of 2. And probability of 0 is 6 combination 0 times 1/3 raised to 0 times 2/3 raised to 6. And then we add it to the probability that x equals 1, which is 6 combination 1 times 1/3 raised to 1 times 2/3 raised to 5. And then the probability of 2 is 6 combination 2 times 1/3 raised to 2 times 2/3 raised to 6 minus 2 is 4. And using your calculators, this will give us 0.6804 or 68.04%. Now, in the next slide, we shall compute for the expected value of the binomial random variable x and its standard deviation. So for the mean or expected value of the number of companies that give employees 4 weeks of vacation after 15 years of employment will be n times p, which is 6 times the probability of success is 1/3, so which is 2. So this means that for every 6 companies that will be surveyed, it is expected that there would be 2 companies that would give employees 4 weeks of vacation after 15 years of employment. Now for the standard deviation, we shall compute it using the formula square root of n times p times q, which is the square root of 6 times 1/3 times 2/3. So this is actually the square root of 12 over 9, which is actually square root of 12 over 3. So please use your calculators to compute the decimal form of this standard deviation. So this ends the binomial distribution discussion. And in the next video, we shall discuss the next discrete probability distribution, which is the hypergeometric distribution.